here is the failed dynamic programming algorithm. All right, and let's understand what fails. And it's good to, it's kind of like the example we did before. Remember when we added the number of lines squared of short, the prettiest way of printing neatly? It's kind of like that. So suppose my input is a bunch of objects, and maybe the solution is just a partitioning of them, right? Just, I think this might have come out of some example that was on a test, right? It was a partitioning of them, and then for each part, there's some way to compute a cost of that part, and then we add them up, right? Suppose that's our problem, right? We can ask the bird for the last part, right? And she can say 10, and then we can give the rest of the objects to my friend, right? And he can partition up the rest, right? And here he has two possible solutions, right? And he chooses between them. And I assume we're getting, I guess we're doing minimum. I didn't know which part, but it turns out we're doing minimum. So he grabs the one with the minimum, right? And then what will my solution be? My solution will combine the friend's answer with the bird's answer, right? Does that make sense? That's dynamic programming as it's supposed to work, right? Any questions about that? Is everybody kind of following? That's another, we just gave another sort of dynamic programming algorithm, right? And then what's my cost, right? My cost boils down to the cost of my friend's answer, right? Plus the cost of my bird's answer, right? And we're happy, right? 10. Right. So here was another solution, right? And this solution is better than that solution, right? That one's not optimal, right? All right. So the point here is that adding 10 to this guy and adding 10 to this guy, right here is my 10 up here. This was, here I'm taking this solution and adding 10 to it, and I take this solution and I add 10 to it, and this is the best one here, right? And this is the best one here. Adding the 10 doesn't change which one's best, right? Everybody get that? And that's just says these differ by 8, these differ from by 8. And so we're good. All right, so now let's change the problem slightly so that there's another cost, which is the number of parts. We're going to add that in, right? Is this going to mess us up? It might mess us up, but it doesn't. It doesn't mess us up because here we're just adding the two costs. Right? Why doesn't it mess us up? Because, well, here, right? Here, I guess, well, here we have 3 parts, right? And we add one part, and here we have 4 parts, and we add 1 part. But in any way, going from here to here, we're making it 1 part, both of them 1 part longer, and we're adding the part of length 10, right? So it still doesn't do us any harm, right? Here, the difference between this and this is here between the 4 and the 5 has the difference of 1. Here, the 3 and the 4 has the difference of 1, right? So it doesn't change any of our problem, right? And if that's confusing you a little bit, here I'm thinking that one way we can count our second cost is simply by increasing the cost of each part by 1, right? So it's still just we're adding the sum of these parts, right? So it's not really that big of a deal, right? Everybody kind of buy that? Now we're going to do something scarier, we're going to put the number of parts squared, right? And now it's going to cause us grief. Why? Because this guy has 3 parts, so we get a 9. And this one has 4 parts, so we get a 16, right? And that bumps that, but yet I was very careful so that this guy is still the best, right? So this one's still the best, but you'll come up here, this 4, now we go from 3 to 4 squared. Here we go from 4 to 5 squared, right? The 5 squared does too much damage. And we switch from this being the optimal to this being the optimal, right? Does that make sense? Yeah, it's non-linear, right? It's non-linear. It's not a, and what does this correspond to? It corresponds to the edge, right? This was an edge that the bird was telling you to take. Is the edge of worth, if it was always of worth 10, we would be fine. If it was always worth 11, we would be fine, right? But here, this extra part is costing us, it depends on the past, right? Here, knowing the friend's answer was 3, then the added, right? Extending the 3 to 4 has a different cost than extending from 4 to 5, right? Because of the square, right? Does that make sense to you? Did I lose you? You look lost.
Yeah, because like we are choosing the minimum cost. So for the 3 and for example, we choose the second one. So that total cost will be 116. But the upper case, we choose the first one, right?
Right. And that's why the algorithm doesn't work.
Yeah.
Right? Because we can't trust our friends giving us his optimal doesn't correspond to us using his answer. Right? Right? Does that make sense? It fails, right? It fails because my friend's solution isn't the right solution for me. Right?